This is Unit 4, Day 3. We're talking about unity inequalities in 1 and 2 triangles today. The first example wants you to draw an obtuse scalene triangle, which I've done over here on the right and label it A, B, and C. First thing it asks is to find the largest angle on the longest side and label them. I've done so. Angle B is our largest angle, and AC is going to be our longest side. Then find the smallest angle on the shortest side and label them also. We can see that C is going to be our smallest angle, and AB is going to be our shortest side. What do we notice? Well, if you notice, the longest side, which is side AC, is across from our largest angle. And also, our shortest side is going to be across from our smallest angle. Using the longer side concept, we can determine which angle is going to be larger. If we're looking at this picture, side AB is 8 and side BC is 5. With this in mind, we know that the angle across from the larger number is going to be a larger angle. Across from 8 is C, and across from 5 is A. Using this, we know that angle C is going to be larger than A. We can use the same idea with the larger angle concept. We know that angle A is 50 degrees. We know that angle C is 30 degrees. Since 50 is larger than 30, the side across from 50 is going to be larger than the side across from 30. So with this in mind, we know that BC is longer than AB. Example 2 asks us to list the sides of triangle RST in order from shortest to longest. In order to find the shortest side, we have to find the smallest angle, and the smallest angle is across from the shortest side. Angle R is our smallest angle, which means ST, which is across from angle R, is going to be our smallest side. Our next smallest angle is T, which is 30 degrees, and that's across from RS, or SR, which is our second smallest side. And clearly our longest side is going to be RT, which is across from angle S, which is 121 in our largest angle. So in order, ST, SR, and then RT. Example 3 wants us to determine the relationship between the measures of the given angles. WXY is this angle right here, is across from 14. XYW is this angle right here, and it's across from 12. Since 14 is larger than 12, we know that WXY is going to be greater than XYW. Next, we're looking at XZY, which is this angle that opens up to 15, and XYZ, which is this angle that opens up to 18. Since 18 is larger than 15, we know that XZY is going to be less than XYZ. And then the third one, WYX, which again is this angle that opens up to the 12, and XWY, which is this angle that opens up to the 15. Again, we know 15 is larger than 12, so we know that WYX is less than XWY. So remember, smallest angle is across from shortest side, and largest angle is across from longest side. We're going to do the pasta example together in class. We're moving on to the triangle inequality theorem, and this is really important to remember. The sum of the lengths of any two sides of a triangle has to be greater than, notice I said greater than, not equal to, or just greater than, has to be larger than the length of the third side. So if we added AB and BC, when we add those two numbers together, it has to be larger than the length of AC. Same thing if we added AC plus BC, it would have to be greater than AB, and AB plus AC would have to be greater than BC. Keeping this in mind, we can find the possible lengths of the sides of the third side of the triangle. It's going to give us a range of numbers. A triangle has one side length of 12 and another length of 8. Describe the possible lengths of the third side. So with our triangle inequality theorem in mind, we're going to find our range of possible numbers by subtracting the two numbers that they give us, and then also adding them. And we know that our number will be somewhere between the difference and the sum. So 12 minus 8 is going to be less than we plugged in x, which could be anywhere of our range of numbers, which is less than the sum, which is 12 plus 8. So our range of possible numbers is between 4 and 20. So our third side is somewhere between 4 and 20. Another example, a triangle has one side length of 26 and another of 19. Describe the possible lengths. Again, we need a range of values. So we subtract, we add, and our possible length is somewhere in the middle. 26 minus 19, which is less than x, which is less than 26 plus 19. So our number is somewhere between 7 and 45. We can use this information when looking for distances. Describe the possible distance from Granite Peak to Fort Peck Lake. Well, from Glacier National Park to Fort Peck Lake is 565 kilometers, and from Glacier National Park to Granite Peak is 489. We know that the third side has to be somewhere between the difference and the sum of the two. So we subtract 565 minus 489, and we add 565 plus 489, and our possible third side is somewhere in between. So our third side is somewhere between 76 kilometers and 1,054 kilometers. Describe the possible values of x in example 6. So this goes back to using inequalities. 13 minus 11, which is less than x plus 7, our x plus 7 goes in the middle, which is less than 13 plus 11. Now, when we subtract 7, we have to do it to both sides. We can't just do it to one side. So we subtract 13 minus 11, which gives us 2. 13 plus 11 gives us 24, and the x plus 7 is still in the middle. So now we're going to subtract 7, which gives us negative 5, which is less than x, which is less than 24. Example 7 says you're bending a piece of pipe cleaner into an isosceles triangle. The pipe cleaner is 24 inches long, and the first bend is 10 inches. Label 2 isosceles triangles you could create. Or if you remember isosceles triangles, that means two side lengths have to be the same. So if we have one bend at 10 inches, one possibility we could have, since they have to add up to 24, we could have two sides that are both 7 inches, and the 10 inches is our longest side. So 7 and 7 and 10 gives us 24, and that makes an isosceles triangle. Or, since we already have 10, we can make another bend that's 10 inches long, which would leave 4 inches for the last side. Either of these two are possibilities.